So let's solve these set questions. Let the sets A and B be given as follows. A is given as 1, 3, and set B is given as 1, 3, and 5. Let me move it down. B is given as 1, 3, 5 is in the question. So let me write this very well. A is given as 1, 3. So now evaluate the following and give their corresponding cardinalities. So for the first one, we have I, A intersection B. So what is intersection? Intersection means the number you can see in both elements at the same time. So look at set A and set B. The element you can see in both sets at the same time is 1 and 3, meaning the element that is common to both sets, A and B. So 1 is in A, 1 is in B, so that means 1 is common. 3 is in A, 3 is in B, that means 3 is common. So A intersection B is now 1, 3. The question also says we should find the corresponding cardinality. So cardinality is just the number of elements present in a set. So number of A intersection B, how many number do you have there? So I have 2. So that means the cardinality is 2. So like that. Use sets. So the cardinality of number of A intersection B is 2. That's the meaning. Just count the numbers of elements inside. So that is the answer for the I. So I A union B. So now A union B means you combine A and B together, but don't write any number twice. Now combine all the elements in A and all the elements in B together, but don't write any number twice. So we have 1, 3, 5. So this will be A union B. So we write all these elements together, but we don't write it twice. So 1, 3, 5 is our A union B. So number of A union B now, that is number of the cardinality, is 3. So out, just count the numbers inside. 1, 2, 3. So that's the cardinality. So 3 I 3 I A slash B. What does this mean in sets? It means what are the elements in A that are not in B. That is the meaning of this representation in sets. So or it's a difference, set difference, A minus B. So what element can you see in A that is not in B? So no element in A that is not in B, so it's empty set. Because I have 1 and 3 here, I also have 1 and 3 here. So elements in A that are not in B, so there is no element in A that is not in B, so it's empty sets. So number of cardinality is null. So that is empty. You can't say 0, because 0 means, if I write 0 here now, it means a member. I still have a member there. So if you want empty set, then you don't write anything in the bracket. So null means empty. So IV A difference B. So what is the meaning of this in set notation? So this means A union B minus A intersection B. So what is our A union B? So we found A union B as 1, 3, 5. Then minus A intersection B, that is 1, 3. So A difference B now. So if you remove this and this, it will remain 5. So that means 5 is the answer. So number of cardinality of A difference B is 1. So I have one number inside. So that's it. So if you have minus, it means if you remove, let's assume you cross, it's not normal minus, but it means the same element, cross it out, then it remains 5. So that is A. From A remove B, that is what it means. So from A union B remove A intersection B. So A union B is 1, 3, 5. So remove 1, 3, so it remains 5. So that is the answer. So 5. So what is this A times B in set notation? It means Cartesian product of two sets. So see the way we are going to have it. So 1, 3 times 1, 3, 5. So the Cartesian product is, so the first element will be times the first element, like 1, 1. So you won't multiply. Again 1, 3, also 1, 5. Then you move to 3, 1, 3, 3, 3, 5. So this will becomes 1, let it be in brackets. So 1, 1. So this 1, 1, again the 1 again, 3, 1, 3, also 1, 5. So now move to 3 again, 3, 1, 3, 3, 3, 5. So do for 3 now. So that will be 3, 1, 3, 3, 3, 5. So that's it. So now number of cardinality. Count all the elements here. That is 1, 2, 3, 4, 5, 6. So there are 6 in total. So answer. So the next one is B part. So we are through with the A part now. So the B part, defined. So define what is a function and demonstrate in a diagram. So let me write a function is a special type of relation in which each element of the domain is paired with exactly one element in the codomain. So a function is a mapping whose codomain is the set of whose codomain is the set of numbers. So example of using diagram. Say we should demonstrate using diagram. So let me just use a 1-to-1 as example. So if this is 2, 3, 4, 6. So let's say this is 5, 7, 9, 13. So write x y. So that is fs is equals to y. So in doing function, so you understand the meaning of this better, but this is just a definition and example, so I won't do more than this. So that's it. So what does this mean? It means we observe here that 5 is the f image of 2. Yeah, that is 5 is the f image of 2. So we can write that as f of 2 is equals to 5. And if we generate the equation for this, you will have f of s should be equals to 2s plus 1. So that is the general formula. So when s is 2, 2 times 2, 4 plus 1, you get 5. When s is 3, 2 times 3 is 6 plus 1, you get 7. 2 times 4, 8 plus 1, you get 9, as in like that. So this is a function that generates this result. So 5 is the image of function, or 5 is the f image of 2. That is, f of 2 is 5, meaning if you put 2 inside this f of s, you are going to get 5. 2 times 2, 4, plus 1, 5. So, but we'll discuss this better in function. But for now, we just have to define function and give example. So this is it. Then let's say number 2. Number 2 question. So simplify the following. When I view these numbers, simplify the following. So we have minus 3 x raised to power minus 4 y raised to power 7 divided by 9x raised to power minus 2 y raised to power 3 everything raised to power minus 2. So to simplify this, so I'll make it faster. You can actually cancel out 3n1, 3n1. So I have minus 1 over 3 times s raised to power minus 4 plus 2. You know this is divide here. So this is s raised to power minus 4 divided by s raised to power minus 2. So that is the same thing as s raised to power minus 4 plus 2. So that is s raised to power minus 2. So because in law of indices, divide means minus, as in like this. So and I have another minus 2. That is how we get plus. So minus times minus plus. So y raised to power 7 minus 3. Then everything raised to power minus 2. So this is minus 1 over 3 times s raised to power minus 2 times y raised to power 4. Everything raised to power minus 2. So this is minus 1 over 3 times 1 over s squared times y raised to power 4. Everything raised to power minus 2. So this is the same thing as minus y raised to power 4 divided by 3s squared. Everything raised to power minus 2. So now this number outside the bracket can affect everything inside the bracket, so it will multiply the powers. So this will be like minus y raised to power 4 times minus 2 divided by 3s square raised to power minus 2. So that will be the continuation. So that is, this power will affect everything inside the bracket. So this will becomes 1 over minus y raised to power 4 square divided by 1 over 3s square. So meaning this power a raised to power minus 1, remember, is 1 over a. So continuation. have 1 over y raised to power 8, because 4 times 2 is 8. Because the power is even, minus times minus will be plus, so I won't have minus there again. That is minus y raised to power 4 times minus y raised to power 4 twice. Minus times minus plus, then 4 plus 4, 8. So that's how we have 1 over this. If division change to times, or let me use divide first, divided by 1 over 9s raised to power 4, because this square will affect everything in the bracket. 3 square is 9. So if division change to times, 9s raised to power 4 will go up, 1 will come down. So finally we have 9s raised to power 4 divided by y raised to power 8. So that's the answer for the first one. So now the second one, B. 2. 124 s raised to power 3 times s raised to power minus 5 divided by 6s raised to power 2, everything raised to power minus 2. So this is the same thing as so this is 24, now 124. So that is 24. So I can say 6 here 1, 6 here 4. So that one can go. Then s raised to power 3 minus 1, because this is divide. So it will turn to minus to subtract that power. Because if you have s raised to power 3 divided by s raised to power 2, that will be s raised to power 3 minus 2. So using law of indices, times s raised to power minus 5, everything raised to power minus 2. So this is 4x times s raised to power minus 5 raised to power minus 2. So this is the same thing as 4s1 minus 5. If you use law of indices, this s is power 1, so add the power. So this will becomes 4s raised to power minus 4, everything raised to power minus 2. So that power will affect everything. So this is the same thing as 4 times 1 over s raised to power 4 raised to power minus 2, because this s raised to power minus 4 is 1 over, so this is 4 over s raised to power 4, everything raised to power minus 2. So if we remove that power now, we have 4 raised to power minus 2 divided by s raised to power 4 raised to power minus 2. So this is 1 over 4 square divided by 1 over s raised to power 4 square. S raised to power 4 square. So this will be 1 over 16 divided by 1 over s raised to power 8. So if division change to times, s raised to power 8 will go up, 1 will come down. So this is s raised to power 8 divided by 16. So that is the answer. So now the next question. we have minus 3 s raised to power 4 y raised to power minus 5 raised to power minus 7 y raised to power 3. So this is minus 15. That is 3 minus 3 times 5, 15. Then s raised to power 4 minus 7. So take one of the s, then add the power. Then y raised to power minus 5 plus 3. So indices. So this is minus 15 s raised to power minus 3 y raised to power minus 2. So if you stop here, you are free, but we can simplify further. 1 over s cubed, this should be over 1, times 1 over y squared. We change all those minus to 1 over, so this should be minus 15 divided by s cubed y squared. So that's the answer for that question. So the next one is 4, 3, y, we think is j raised to power minus 12 s raised to power minus 2 divided by k raised to power minus 4, everything raised to power minus 3. So that power 3 will affect everything. So this will be j raised to power 12, and 12 times 3 is 36, j raised to power 36, s raised to power 6, k raised to power 12. That is, this 3 minus 3 will multiply every powers here. So a minus times minus is plus. So here 6 is common to that power at the numerator. So this will be j raised to power 6, x everything raised to power 6, because 6 times 6 is 36, and this power is 1. 6 times 1 is 6 over. This one too can be k raised to power 6, k raised to power 2, then everything raised to power 6. So power 6 can be common. This can be j raised to power 6s over k square, everything raised to power 6. So if you like, you can go further this way, and if you like, you can stop here. If you like, you can still stop here. So that is the answer. So the B part of this. So we have the total number of students taking Python. So let me represent Python as P, or linear algebra. Let me represent that as A. At USIU is 50. So that is universal set. So that means number of, let me start with the universal. That means number of universal is 50. 15 takes both linear algebra and Python. Number of algebra and Python is equals to 15. How many students take Python? If the total number of students taking linear algebra is, so number of students taking linear algebra is 22. So use Venn diagram to prove your answer. So these are the informations that we know. Then we need number of number of Python. So how many students take Python if 22 take linear algebra? So we are going to put this on a Venn diagram. So we have this. So we have our diagram. This way. So now universal is 50. Number of linear algebra 22. Number of Python unknown. So we don't know the number of Python here. Question mark. So both is given as 15. So like that. So this place is easy to know. So this place is now 22 minus 15, as in that place. So total number there is, but if I show it in workings, let's call this place A, this place B. So everything inside this circle here, everything inside this circle is 22, as you can see it here. So let's add everything equals to 22. So I have A plus 15 equals to 22. So A equals 22 minus 15. A is equals to 7. That means this place is 7. So now we need to find total number of everything in this circle must be universal. So that means we know A to be 7 now. So it will be 7 plus 15 plus B. So everything must be equals to the universal 50. So now collect like terms. 7 plus 15, 22, plus B equals to 50. B equals to 50 minus 22. B equals to 28. So we know here now to be 28. So because we know that place, so we can now find. The question says number of how many students take Python. So the question did not say Python only. Question say how many students take Python. So that means everything in this circle represents Python, but 28 take Python only. So that means number of Python now is 28 plus 15. So number of Python is equals to 28 plus 15. So add it together. So that is 43. Answer. But if it is number of Python only, that is 28. So here now, this Venn diagram means number of linear algebra is 22, that is 7 plus 15. Number of linear algebra only, that is 7. Number of Python and linear algebra, number of Python is 15 plus 28, 43. Number of Python only, so that is 28. like that. So that is the answer. The answer is 43, number of python.